Okay, now let me show you a real-life example of a simple DC motor. I found this YouTube clip and you can have a look.
Right now we won't see any continuous rotation because we're missing one thing, and that's the
So what's happened is the guy has a current connected through a coil, okay, through a coil, and because there's no magnetic field, so it won't rotate. Okay. However, if we can, well, have a look. If he when he place the magnet under it, it starts rotate. So
static magnetic field for the coil to work against. I'm going to move the magnet into position, and we see that the motor starts to run. This coil will continue to operate as long as we have the magnetic field present by keeping the power turned on, or as long as the magnet isn't present. If we remove the magnet, the rotations will eventually stop. So what's happening is the coil is generating a magnetic field, and it has a north and south pole just like normal magnets do. And when we put this magnet in place, of course, the opposites are going to repel each other, like are going to attract. So as we move through here, this is very rapidly turning on and off as this axle rotates in this holder.
okay, so yep, so this is how simple to build a simple DC motor, and yep, so this one build is slightly different than what we introduced, but just show you an idea. However, now let's talk about commutators. Okay. Now sometimes they also called split ring commutators. So just don't get, just make sure split ring and commutators, they are the same thing. Okay. Now, well, as what we talked about before, in a proper design, proper industrial design of a DC motor, okay, the commutators makes sure that the current always go into the page on left hand side or right on one side and come out of page on the other side. That's what does. That's basically what does it do. So okay. So the reason commutators are important is, I mean, for VCE, for you, the reason for you is the exam, and in reality, it is important because without the commutator, the DC motor could not work. I show you what does it looks like. So let's just go to Google and search for it. Just remember, those DC motors, they are, in reality, is three-dimensional. So here is a better picture of a commutator. Okay. So the commutator is basically a half circle ring and empty inside, so the current can flow in one side no matter how it tend. And in reality, yep, we can call this a commutator. They have three. It's just just this design makes the motor works far better. Okay? But I try to find a simple one, a picture of a simple commutator for you. They really do looks like that. Okay, so yeah, so you see they have coils in the middle. They have a rubber coil. That's insulator. Then what's happening is you connect one terminal of the battery inside inside, and you connect the other coil outside. Okay, so and they are able to turn 360 degrees. So yeah, so yeah, I know that the commutator looks very different than what is drawn on the diagram, but yeah, in the diagram it looks like this, but in reality there are plenty of different designs. Okay. Yeah, the most popular one will be this one. Will be this one there. Okay. You have an insulator in the middle, and you have a conductor inside, and another row of conductor outside. So you are able to put the battery, like put it somewhere in. Okay. But yep. Now let's talk about exams. So in the exam, when they talk about commutators, you need to mention that what does what's happening is in the exam, they ask students what does a commutator do, why commutator is important, and a lot of year 12s get them wrong. So yep, so that's why we're doing it. So in the exam, you need to mention that the commutators actually um, make sure it ensures that the direction of current on the left hand side and the direction of current on the right hand side doesn't change. Okay, so that the direction of current on the left and on the left side and right side, okay, does not change. Okay, even through yep, okay, then when the motor rotates, okay, when the shaft actually use the proper word, when shaft rotates. So what's happened in the exam is, now a lot of students, okay, they understand the concept, and they understand the function of the commutator, but they cannot explain it. But if you have a look at those side views, in this particular motor on the left hand side, current always goes in, and if you look at the other picture, on the left hand side the current always goes in. On the right hand side, the current always come out of page. So the role of commutator is, the commutator ensures that. Okay, so okay. Now, once you mention that, you also need to mention that the commutator, well, if you mention that, you only get one mark out of 3. Also, you need to mention that the commutator, by doing this, the commutator makes the motor, makes the coil, which is the wire A, B, C, D inside the coil, rotates at the same direction. And one more thing you need to mention, okay, well, just let me explain this. Okay, the coil is basically, I write it down. The coil is basically your line A, B, C, D. Okay. The thing that rotates in the motor. It's called the coil. Now, yep. Uh, Also, it is better to write down. Okay. Also, the commutator reverses. Okay. What does it do? It is okay, reverses the direction of the current, okay, in the coil, okay, every time it every basically every 180 degrees. Okay, so if you look at now, if you look at this picture, the current flows from A, B, C, D. Okay. Now, after it switched side, okay, after it turned 180 degrees, the current flow from DCBA. So, yep. So just write these three things down. You get three marks.